Welcome to Breadboarding. In the previous video, we looked at the COMPAQ DeskPro 386 32-bit system memory board. We're using the DeskPro 386 as a basis for our 386 breadboard PC. And in the previous video, which will be a link at the top right-hand corner here, and went through a lot of the background to how that card worked, and we went through the schematics and looked how we're going to be designing it. Now, the original card came with 1 megabyte of RAM pre-populated, and it came with sockets to plug an extra 1 megabyte in. Now, to have 2 megabytes of RAM on this card, you needed 72 dynamic RAM chips, and these were 256k times 1 bit. Now, we're going to be simplifying that by quite a bit by using 4 512k by 8-bit chips. So we covered the schematic in quite a bit of detail in the previous video, and one of the challenges here is an awful lot of wires going around the place. So you'll see here with the data bus here, we've got 32 lines coming out of the CPU here, coming into these buffers here, and these all need to go up to the data bus buffers up here, and then they'll be wiring them up to the chips from there. And then there is the processor address bus, and these actually need to be wired into here because I didn't do that earlier in the series because we didn't need this, but now we're going to be needing to wire these over to here and also up over to these buffers up here. And then on the buffered addresses on the memory card, these then all need to be wired up to these chips here. And then we've got all of these signals and things for the chip enable logic that we need to wire up as well. Now, early in the series, I covered quite a neat way to wire up these things without using vast numbers of rainbow DuPont cables. So in video 12, which will be a link at the top right-hand corner here in the description below, I covered how to use these 0.1 inch pin headers and actually use a wire wrapping tool and wire wrap wire to actually wire these together. So what we're going to be doing during this video is wire wrapping into these connectors down on the CPU part of the circuit, adding some more connectors in here, wiring up all of this address bus down here, and then the data bus and the address bus for the CPU are going to be going to our memory card, which is going to be up the top here. So this is video 21 in the 386 Breadboard PC series, and this is part 2 of the 32-bit memory board, in which we're going to start laying out the board and wiring it up. So in the previous video, I covered the layout of the board, and the layout pretty much matches the schematic. So I try and make sure that the schematics from my breadboard projects are actually laid out in a way that is almost going to be the physical layout. This avoids any extra complications. So I've now put chip labels on all of the chips. They've all got chip labels that actually refer to the actual signals on them to make things less likely making mistakes. And what I have done is I've made a lot of these connectors. So these are the connectors that I use with the wire wrapping. So if you look in video 12, then you cover the use of the wire wrapping tool. There's sort of multicolored wire wrapping wire that I use for actually making up cables. So basically, this replaces using these sort of DuPont cables. Now, these are great cables. Don't get me wrong; they're very useful for using in the projects. However, when you've got so many connections here, we'd end up with so many of these cables around the place. It would be really difficult to see what was going on. Now, because wiring these things up using wire wrap does take quite a long time, what I'm going to be doing is sort of going off, wiring everything up, and then coming back once all the wire wrap's been done. So having laid this lot out, what I'm going to do now is going to actually start wiring up all of the normal wires, and then we're also going to be plugging in all of these connectors. So for example, we'd have a 12A connector, for example, for all of the address lines on the RAM chips, for example. So I'm going to go off and do that, and when we come back, then we should be ready to actually start doing all the wire wrapping. Okay, so I've now put in all of the power connectors, put in all of the tying to ground and to 5 volts for all the chips. I've actually done some of the signals. So these are the parity 0 to parity 3 are tied to 5 volts down here. I haven't done every single tie up to ground, and 5 volts for all the other chips up here. We'll do that a bit later. Now, I've made a lot of these connectors here that I showed you previously, and the way how you do that, you can see here it's quite a long connector, but it's got a double plastic sort of bit there that makes it just a bit stronger for keeping the pins together. And the way how you make those is take a standard bit of the 12mm strip. I just pull the pins out of those, using a pair of pliers. That gives you the plastic strip like this, and then you find the right number of pins you want, then basically use the pliers just to squish this on, and then you can just use the pliers to move the pins so that they're sort of more balanced like that. So that's how we make those, and this is the type of connector we're going to be using for all of the wire wrap a little bit later, but I'd prefer to do all of the main wires first before we do the wire wrap, and then the wire wrap will go over the top. So first of all, we're going to be wiring up the data lines for these, and we'll also wire in the chip enables. So the chip enables are coming from here to here, here to here, here to here, here to here. You just want to get the chip enables in before too many of the wires and things get in the way. So these are the chip enables, goes over to the CE here, and when I've got the 5 chips within each socket, then these other chip enables will be going to some of the pins over on the right hand side here, which will then in the adapter will connect to chip enable on the first, second, third and fourth chips which are above this particular chip here. So we've also got chip enable for byte 1, chip enable for byte 2, chip enable for byte 3. We've done the chip enables, now we just need to wire up the data bus. So the data bus, so this is the memory data bus, MD. We have MD0 to MD7 here, going to MD7 to MD0 over here. And then similarly, we've got MD8 to MD15, going to MD8 to MD15, MD16 to MD23. And then over here, we've got MD24 to MD31 going over here. So I'm just going to wire those up, speed it up. That's the main memory data bus, so the processor data bus is going to go onto these ones through the wire wrap going down to the bottom of the board there, and then these ones are just going to the RAM chips. So there's 2 other memory lines, MD0 and MD1, that need to go over to the flip-flop over here, which provides the register for the memory configuration. So look at MD1, so he comes out of here and goes up to 1D on this chip here, and then MD0 goes on the other side of that chip. So that's the data lines done for the moment. Now we need to wire up some of the buffered address lines. So you'll see that the processor address comes in from here over wire wrap, and then all these outputs, we need to initially wire these over to here. So there's 3 here and 5 here need to be wired into here. And then we also need to sort out the F20. So this is one of the lines that handles whether or not the A20 line is passed through from the processor or whether it's set to 0 to enable older software that doesn't work above 1 megabyte to work properly. Now I use green for the address line, so I'm just going to wire the green address lines up. Okay, so now we just need to do the jumper settings. So these are the memory card jumpers. Now we're going to hardwire these. So we've got the 512K, 640K, 1 megabyte, 2 megabyte, and there's also the 8 megabyte there as well. And for the moment, we're just going to be tying these. So the 8 megabyte and 2 megabyte are the expansion cards. So those are going to be tied to 5 volts. The others 2 here are going to be tied to ground, and 512 tied to 5. And then we need to connect those over to this port over here. And we also need to connect the parity read signal as well as these other ones here. So the parity read comes all the way over to the RAS PLD over here. Now we need to hook up the memory 32. So you can see here that we need to hook these 3 pins together, and then the output here needs to go off to this PLD over here. So this is the control PLD. We're going to put a little flag in here as well, because this is going to need to be connected down to the rest of the system board. You can see that we've got some connections down here as well that we need to hook this up to when we connect up to the main system board. Now we need to sort out the CLAT signal. So this goes from this PLD here down to these 4 address buffer chips. So we just need to wire one of these down to here, and then we'll just connect these 4 chips up together. Now we need to do the BS0 to BS3. So this is coming from the Byte Enables signals down from the CPU. So we'll have to wire those in once we wire up the system board. But the buffered outputs here, the BS0, BS1, BS2, BS3, goes up to this chip here, and we also need to wire in the memory read signal from over the output here. That needs to be wired into these 4 inputs to these gates. So each of the A inputs to the gates will have the memory read, and then the BS0 goes into the other input, and the output will be our chip selects. And those chip selects, once we've actually got them in a position, will go over to these chip enable chips over here. So CS0, 1, 2 and 3, and that will do the enables for each of the individual bytes. Then we need to do the other memory read signal. So the memory read needs to go off to the first chip here, and then our wire app connectors will then plug all of these wires on each side here up to the subsequent chips. So we just need to wire it into here. We also need to do the write enable output from there, which again needs to go into this first chip. And then we've also got the memory write enable that needs to go around to here, and the memory read also needs to go around to here as well. Then finally we need to hook up the BA31 to BA21, which needs to go down to these chips here. So we can pick up those signals from here to here. That's going to wire up to here, and then again the connectors which are going down between these 4 chips will take care of the rest of them. Okay, so now we need to wire up some more of the signals here to over here, and then that'll then mean these other headers here can then be used for the wire app a little bit later on. So we're going to be plugging in the MRAS, which needs to go all the way over down to here. MCAS goes alongside it, then RS0, which just needs to come down to here, and RS1 comes down to here. So we just need to go and wire those up. So now we need to finish wiring in the remaining signals on this PLD here. So we've got the write protect input from this flip-flop over here, the parity write, which also does the writing to these 2 registers, which are used for the write protect of the upper area of RAM and the relocation of the ROM. We've done the read, the WE0, the write enable, the read enable, the RS0, and then just refresh is the only other one we need to wire in up here. So we'll just go and wire those up. So now we're going to just wire up the rest of the signals for this chip here. That is MU8, which is a flip-flop, 7474 series flip-flop. So there's a couple of pins we need to worry about. So we need to tie the clear to 5 volts on both sides. We've already done the data 0 and the write line, which is a clock. We need a reset, which is going to come from elsewhere on the board. We need to connect that round to here. Then the ROM signal, which has got an M prefixed on it for the memory board, just because it will conflict with the main board. So that needs to go down to our PLD here for the ROM. So this is the signal that tells the PLD chip here that we're mapping the upper 1 megabyte of system BIOS ROM up into the top of memory. So when that is active, then that will actually do that mapping for us. So now we're going to wire in a few more signals for the control PLD, which is this one here. Now there are a number of signals that are going to be coming from the main system board coming in here. So things like the WRDC, some of the clock signals and things. So those will be coming in probably straight into there, but we just need to wire a few other signals. So let's have a look at those. So this is the chip down here. So you can see the hit here is just going to be wired to high to start with. So if it's wired to low, then it will actually speed up the memory accesses. This is the part that allowed the dynamic RAM. It would detect whether or not the higher part of the address was the same. So it's on the same page and it could do a faster memory access. So to start with, it will be disabled. Then we need to connect up clock 16 to the rest of the board. When we do that, we also got hold A, but that needs to also be connected up to these two chips up here. M32, I think we already have connected, so that's already wired in. Then the WR is just going to be going off to the main board there. DC, also off to the main board, but also needs to be connected up to here. The delayed memory I/O needs to be wired in up here. And this basically takes the memory I/O, is clocked by the clock 32, and that will just delay the memory I/O signal by 1 fast cycle. Then the address strobe memory comes from over here. So this address strobe is only active when we've got the memory rather than the I/O side of things. And clock 32 is going to be coming in, but needs to be wired up to here as well. And that will be coming in from the main board as well. Then down on the bottom, we've done most of these signals. So the RAS SWM is not used. We do need to worry about the next address memory. That needs to be wired in up here. And again, this will be going off to the system board. The CAS, we've already done. Memory ready, again, this needs to be wired off to the main board. The write enable and the read we've already done, and the CLAT as well we've also done. So there's just a few of these signals we need to put in, and I might just put in sort of a flag pin on those which we're going to need to connect up to the system board in the fullness of time. So now we're going to finish off wiring up the last two chips here, and there's a few other little bits that we need to tidy up. So the hold acknowledge coming out of this gate here that we fed this one in the previous step, we need to feed this round to here and over to here. The memory I/O, so memory I/O is going to come in from over here, and we need to actually wire this up to here and to here, and then the inverted memory I/O comes out of there and is actually going into this chip here. Then we've also got the LA20 coming out of Q bar here, going into 2A here. And we also need to put in a sort of flag for the low A20, which is going to be coming from main system board down here. So that's all of the normal wiring I've done here now. So what we're going to be doing now is using this wire wrapping wire and a wire wrap tool. And what we're going to be doing is wiring up these sort of 8-way connectors up the top here. So first pin there goes to there, to there, to there, and all the way along. So that's going to be wiring up all of the chip enable inputs for these PLDs over here. Then there's the address lines, the buffered address lines down here for the memory board. And these are going to need to go to here and to here. And then each one of these is then pin 1's going to go to here, all the way up to this pin's going to go to there. And then those just need to be connected all the way up there. And then similarly, all these ones are going to be connected all the way up here. We've just got an 8-way to 8-way here for the data lines here. So pin 1 there is going to go to pin 1 there, pin 2 to pin 2, etc. And then once we've done all that, then we're going to need to fit this alongside the main system board. I'm going to wire in the data bus connections down the bottom and the processor address bus along the top here. And then where we've got all these little wires here, I'm going to put the labels on there for where those need to be wired up on the system board. So things like the memory 32 and the CPU control signals, for example. So I'm going to often do that off camera because doing the wire wrap does take quite a long time. So when we come back from that, we should be then ready to fit the memory card to the main system board. It's now a couple of days later, and I just took some photos of the wire wrap as I was actually going through. So you can see across the top there, I'd actually done the wire wrap up there. I'd done a lot of the wire wrapping around here to the first RAM chip here, and then these were all the other wires then going across here. So this was before I'd actually tidied these up. So normally what we do is we sort of pull out the socket and twist it around a few times and perhaps put some black wire around the bundles here just to keep them. So that's the size of it when it was before the tidying up. You can see there that it's been tidied up there. So it's a fair bit smaller once it's had that done to it. So then this is the other one here. So on the lower side here, you can see that is all sort of loose for the moment and takes up a bit of space there. And then when I've actually tidied it up, you can see it's a bit neater there. And then over here, you can see where all these blue wires are. These are where I was going to put the sort of labels or flags on there, just to indicate where the various control signals need to be plugged back into the main system board. So this photo here, you can see we've got the memory 32, the reset, address strobe, low A20, clock 32, all these sorts of lines. So what I'm going to do is I'm probably going to break the video soon just because it's going to take a little bit longer to wire everything up to the system board and to sort out some test software. And this is just a reminder of what the original 32-bit memory board was. Now I've sort of approximately measured this. So this connector down the bottom here is 40 pins, 0.1 inch. So that's about 4 inches. So the card is about 5 to 6 inches high and about 14 inches wide. And this is the current state of the card. And you can see it's approximately about 6 inches from top to bottom, and it's about 13 inches across. So it's a similar sort of size, nowhere near the sort of chip density that the original memory card has, since we've managed to get 2 megabytes of RAM in these 4 chips, whereas the original DeskPro needed 72 RAM chips, I believe, to get 2 megabytes of memory. So in the next video, I'm going to be wiring up all of the bus signals down here. So this is the processor data bus and the processor address bus into the main system board. And then we'll also look at programming some RAM test software just to do a simple test of the system RAM. So if you don't want to miss out on future videos, then please hit subscribe. If you could hit like as well, it just helps to make the videos available to more people. If you'd like to leave comments below, I do try and get back to you within a day or so. Thanks for watching.